Compared to the other sections in chapter 6, 6.5 is a good bit shorter and I think a good bit simpler than the other things. In this section, what we're looking at is finding the average value of a function over some interval. Let's see, I'm missing a parenthesis there. So this is slightly complicated by the fact that when we take the average of a function over an interval, we're taking the average of an infinite number of values. But it turns out it's not that bad. We're going to see how to do it. So I want to start out with a few sort of simple examples. So find the average value of f of x equals 2 over this interval. All right, f of x equals 2. I mean, that's just a constant. So over the interval from 0 to 4, so here's 4, we're looking at the average value of this thing. Well, the average is always 2, so or rather the value is always 2, so the average has to be 2 as well. All right, not a whole lot to get from that. But let's look at this next one. Find the average value of f of x equals 2 minus 1/3 x over this interval. Now, if you graph this out, 2 minus 1/3 x, if you graph it, you'll see this is the graph. It starts up here at 2, and it goes down to 0. So you might look at it and say, well, half the stuff is below 1 and half is above 1. And not only that, but for any value you pick over here that is above, I'm gonna draw in 1. For any value you pick over here that's a certain distance above 1, you can come over here and find another value that's that exact same distance below 1. So a reasonable guess, and this is correct, is the average value is 1. But here's another way we can look at this. Let's look at the area underneath here. If you look at this area is, let's see, it's 4 by 2, so the area is 8. And down here, if we look at the area underneath this, the area is, we could integrate it, but it's just a triangle. The area is going to be 6. Yeah, because it's 2 by 6, and it's a triangle, so 1/2 base times height is 6. So notice, if you take the length times the average height, what you get is the area. In this case, the length of the thing is 6. The area is 6, and so the average height is 1. And ditto up here. The length is 4. The area is 8. And so the average height is 2. So if you have a function where it's not easy to look at it and tell immediately what's the average value of it, you can just use this. The area under the curve is equal to the length of the interval times the average value of the function. And if you rearrange that, you get that the average value is equal to the area, and this is like dividing by the length. So this is the formula to memorize from this section. The average value of a function is 1 over b minus a times the integral from a to b of f of x dx. Now, I skipped over a couple of things here. In order for this to work, the function has to be a continuous function. But let's look at some examples. Find the average value of f of x equals sine x on 0 to pi. Now we know up here the top value is 1, and it's a 0 down there, so the average value's got to be between 0 and 1. If I were to guess, actually I don't know if my guess would be any good. Let's just work it out. So this is our a and b. So the average value is 1 over b minus a to b of sine x dx. Of course, we plug in our b and a. This is 1 over pi times the integral from 0 to pi of sine x dx. Now remember, when you integrate sine, you get negative cosine from 0 to pi. So let's see, if you plug in pi, you have to remember our values of cosine. Cosine of pi is negative 1. So this becomes positive 1. And cosine of 0 is 1. So we've got, let's see, a negative and a negative. So this is plus 1. So it looks like what we get out of this is 2 inside of there over pi. And what is 2 over pi? .6366. So if you were to draw this in up here, it's going to be something about like that. A little bit bigger than a half. All right, let's do one more. Find the average value of square root of x over the interval from 0 to 9. Well, this is going to be 1 over 9 minus 4 times the integral from 4 to 9 of square root of x dx. So 9 minus 4 is 5. This is x to the 1/2 dx. 4 to 9. Let's see, when we integrate that, you get x to the 3/2 with the 2/3 on the front. So let's see, 1/5 times 2/3, that's 2 over 15. And then we get x to the 3/2 from 4 to 9. So let's see, 9 to the 3/2 minus 4 to the 3/2. Let's see, 9 to the 3/2, that's square root's 3, cubits 27. 4, when you take the square root, you get 2. When you cube it, you get 8. So you get 2/5 times 19, or 38 over 5. All right, and that's really all there is to this section.